All right, we are now being recorded. We're all, well, some of us are here. Look, I don't really want to get up at 5:45 on Saturday morning either and do all the prep I have to do and come here. So where is everybody? I so appreciate everyone coming that's here. Don't get me wrong. I'm really glad you guys are here, but there's 11 participants. And if I subtract me, Ugo's support people, that's 5. We've only got 7 students total out of a class of more. So you guys want to hear me wank some more? Probably not. I don't want to hear myself either. So
Now you know when they come for a job, you'll say, "Weren't you in my class and you never showed up on Saturday?" That's their commitment to themselves.
well,
You got to commit to yourself before you can commit to anybody else.
not to mention any names, but I got an email this morning that said, I can't make it to class because I've got to work this morning. I've got to be on a job. I've got to be on a job for an estimate, something like that. It wasn't work, but so I emailed back and said, okay, but you have a commitment. Wait, you have a commitment on Saturdays. So why would you schedule something when you have a class commitment? And then when I got here, I got an email back that said, oh, I'm helping my dad translate, and so that's great. And I emailed back, said that's great. I'm really glad you're doing it. I really hope your dad gets the job, but perhaps you could let your dad know that you have a commitment on Saturday. So, just not to beat this horse to death, but commitments are very simple. It means that when you say you're going to do something, that you do it no matter what. I don't care what's happening. A commitment means you're going to do it. Now, just because I said I don't care what's happening, that doesn't take away the fact that there are real emergencies in life and real, even, maybe not physical or life-threatening emergencies, but emergencies that get in the way of you keeping your commitment. That's okay, as long as you communicate. So in that respect, the person who shall remain anonymous did
Trust me, Rodney. I appreciate that you guys get up every morning. You know what I mean? I appreciate all the time that that all the teachers, all the classes that I take. I appreciate you guys' time. I remember my kids, they would get mad at me. You know what I mean? My daughter, she was a roughhouser when she was younger. And she'd be pissed because me and my wife would punish her, and she's all, but all I done was, I was just letting the teacher know. I said, but look, you wasted her time. You wasted all the children's time who got up to go to school that day. I go, because you wanted to make a statement that had wasn't even worth arguing about. She goes, yeah, but you always told me to stand up for myself. I said, yeah, but you got to pick and choose what was good to stand up for. You know what I mean? Not because you need to use the restroom and you got to wait an extra 5 minutes. Come on, but you know what I mean? I do.
I'll make you my sergeant at arms. So I'm going to take roll. Okay, I'm going to take roll. So unmute yourself and answer me when I call your name, please. On this Saturday on 3/13/21, Dario. Oh, Dario, I don't think you're going to ever come, are you? See, I don't think I've ever had to or been able to put a check next to Dario's name here. Nope. I have a talk with Dario. All right, Jesus. Donna. Armando. Emmanuel Gutierrez. Brenda Landeros.
Here.
Jose Landeros.
Here.
Catherine LeMay is camping. at Lake Lopez. But she's also taken this as pass, no pass. So I'm giving her a pass. Plus, she's a really good friend. Colby.
Here.
Hugo.
Here.
Eric Mendez. Kevin Velasco.
Here.
D. D'Angelo Rangel. Joshua Santana. Josh.
Here.
Thought I saw you. There you are. It's cold in here. John Sesser.
Here.
Michael Silva. Michael's doing something. I talked to him last night. I think anyway. He communicated with me. Jose.
Here.
Where are you, Jose? There you are. Aurelio. I see Aurelio and Vega. Dennis Vega. Dennis has to work. So, if you have to work, it's not something you schedule, like Dennis works for a framing contractor. That's a good excuse. I'm not going to say, oh no, man, you can't make money to support your family. You've got to come here and listen to me, my long-winded talks. I'm not going to say that. Okay, so one more time. Did Dario come in? Donna, Mondo, Manny, Eric, D'Angelo, or Aurelio? No. Okay, let's pick a roll. As it's been my habit to do, these few Saturdays I've been doing it, I'm going to read you a little bit about, I'm going to read you a little bit from the 4 agreements. A couple of paragraphs. This is still in that first chapter, or the chapter about the first agreement. And it's talking about words and about us being magicians as human beings, and using our words being magic. Looking at everyday human interactions. Imagine how many times we cast spells on each other with our word. Over time, this interaction has become the worst form of black magic. We call it gossip. Gossip is black magic at its very worst because it is pure poison. We learn how to gossip by agreement. When we were children, we heard the adults around us gossiping all the time, openly giving their opinions about other people. They even had opinions about people they didn't know. Emotional poison was transferred along with the opinions, and we learned this as the normal way to communicate. Gossiping has become the main form of communication in human society. It's become the way we feel close to each other because it makes us feel better to see someone else feel as badly as we do. There's an old expression that says misery likes company. It actually is misery loves company. And people who are suffering in hell don't want to be all alone. Fear and suffering are an important part of the dream of the planet. They are how the dream of the planet keeps us down. I'm going to read one more. Using the analogy of the human mind as a computer, gossip can be compared to a computer virus. A computer virus is a piece of computer language written in the same language all the other codes are written in, but with a harmful intent. This code is inserted into the program of your computer when you least expect it, and most of the time without your awareness. After this code has been introduced, your computer doesn't work quite right, or it doesn't function at all because the codes get so mixed up with so many conflicting messages that it stops producing good results. Human gossip works exactly the same way. For example, you're beginning a new class with a new teacher and you have looked forward to it for a long time. On the first day of class, you run into someone who took the class before you who tells you, oh, that instructor was such a pompous jerk. What? He didn't know what he was talking about. He was a pervert too, so watch out. You're immediately imprinted with the word and the emotional code the person had when saying this, but you're not aware of his or her motivation in telling you. The person could be angry for failing the class or simply make an assumption based on fears and prejudices. But because you have learned to ingest information like a child, some part of you believes the gossip and you go on to the class. As the teacher speaks, you feel the poison come up inside you, and you don't realize you see the teacher through the eyes of the person who gave you that gossip. Then you start talking about to other people in the class about this, and they start to see the teacher in the same way, as a jerk and a pervert. You really hate the class, and soon you decide to drop out. You blame the teacher, but it's the gossip that is to blame. All right, I'm gonna read one more, I swear, only one more. All this mess can be caused by one little computer virus. One little piece of information can break down communication between people, causing every person it touches to become infected and contagious to others. Imagine that every single time others gossip to you, they insert a computer virus in your mind, causing you to think a little less clearly every time. Then imagine that in an effort to clean up your own confusion and get some relief from the poison, you gossip and spread these viruses to somebody else. Well, let's not do that. I'm going to pause for just 1 second and turn on the heater. Raise your hand if you had breakfast this morning. Okay, and Jose. I'm not raising my hand because I didn't. Well, I cut this pineapple. I'm the best pineapple cutter there is. All right.
My favorite fruit.
Is it really?
Mm-hmm.
My wife and I have this thing because it's called pineapple, and it's not the fruit. Pineapple is when she says something that's a duh, which means, she said it at least 24 times or more, the same thing. So, and it's called pineapple because it seems like every time I open a pineapple or we're about to eat pineapple, my wife chimes in at some point with, yeah, I've heard pineapple is really good for your digestion. So it's just, she said that enough about pineapple. Oh, really? You think it's good for your digestion? I've heard that somewhere before, that we kid each other about that. So when we say stuff like that, it's like, I just go pineapple, pineapple. In other words, I've heard it before. But yeah, I love pineapple. And it's really good for your digestion. So I'm going to just double check. Dario, Donna, Armando, Emmanuel, Eric, Mendez.
Thank you for the words this morning. Appreciate it.
Oh, you're welcome, Jose. My pleasure. Aurelio? All right. We'll keep going here. Where was I? I got kind of short-circuited this morning because I had some stuff, some logistic stuff to do. And in keeping with now, I don't want you to think this is gossip because it's not. But interpersonal relations affect us all. So I like to keep mine as clean as possible. And this morning, it was starting to go south. My communication was starting to go south. So I really made a concerted effort to stop and get the communication right and get the energy right, so I would feel peaceful in myself and centered, so I could come here and give you guys all that rather than me like irritated. Ooh, don't you hate to be irritated? Ah. Can you see that? And actually, I know Ugo doesn't get to see this as big, but hopefully you can see that. Anyway, it's just a brochure for MP Aero, and you know, if you look at the pictures, there's all kinds of interiors, really jazzy interiors on these planes. Okay, and the reason why I'm showing you this is because I was at my old shop yesterday. And I was talking to Victor Lima. And Victor Lima is, let's go back to gallery view. Okay. Victor Lima works for my old company, and I've done some work with him. He's a very accomplished cabinet maker. He used to work for Charlie Starbuck, and you know, they did all this stuff for Oprah Winfrey, but he has also done a lot of aircraft work. He worked for Garrett Aviation. I don't think he worked for Tracor, but he's done a whole lot of aircraft work, which is a specialized field in cabinet making and woodworking. And it's not one that a lot of people know about. So if anybody's interested in something like that, if you think you'd really like to go into the finer aspects of woodworking, you know, ask me about it and I can point you in a direction you may want to go. But there's all kinds of opportunities in this trade, and more because there's less and less people to do it. Less and less qualified people. And what I mean by that is most of us qualified people are old, and we're not working. We're getting ready to retire. So it's the younger people, they're going to carry this trade on. There's another trade that people don't even know about. For instance, I bet nobody here has any idea what a pattern maker is. Am I right? Where's John? What happened with John? Does anybody here know what a pattern maker is? Anybody that I'm seeing on my screen? I didn't see anybody raise their hand or say yes. So I'm assuming that no one knows. Let's see what happened to John. Oh, okay.
I know what it is when it comes to sewing.
Yeah. Okay. No, I got that, but that's not what I'm talking about. But that's a good point, because not a pattern maker when it comes to sewing. So pattern makers make the patterns and molds are typically woodworkers, but you know, anything that, well, I might be wrong on this, because nowadays with computer modeling might be replacing pattern makers, but typically pattern makers made everything that got manufactured as metal or plastic, and molds were made. But to make the mold, you had to make the pattern. So it had to be made out of wood or something that could be crafted into what you wanted the final product to be, and then molds could be made off of it. So there are still pattern makers and jig makers, and it's a higher form of woodworking, but and an esoteric form, but it's also a place where you can make some good money, pattern makers. And I'll find out more about it. I just started thinking about it yesterday when I was at the shop and I ran into Victor Lima. Let's
Yeah, my dad was a mold maker for Mattel Toys, but he also did a second job at home, and he's made molds for like Toyota, and he's done like for computers and things. And I remember him, you know, like it would be made out of wood. It would look just like a computer, and it'd be made out of wood, you know?
That's so cool. That's
yeah,
cool.
it was
Great.
really neat.
Is your dad still alive?
Yes.
You should interview him about that.
Yeah,
He's good knowledge to have. You know?
Oh yeah, I wish I would have learned all his woodworking skills.
He made two great things that he's known by too. He done the structure outside of the Epcot Center, and he also done California raisins.
Wow, that's really cool. And I just want to say that my father, I lost my father in 1989. So that's been 33 years ago. And I miss him every day of my life. And whenever I think of him, I don't like to have regrets, but I just regret that I didn't spend more time with him. And I didn't ask him more questions about his life, you know, and about what it was like to be in the Argonne Forest in 1944 and be 20 years old and be fighting World War II. It was unbelievable. I mean, that all that's gone, all that part of my family that experienced that is gone. And I was too young and too stupid, I guess, to ask the questions. And when as I grew older and got a more of an appreciation for everything in my life, the people that I really wanted to find out stuff from weren't on the planet, or at least weren't alive anymore. So don't take it for granted, please, and spend as much time with your folks as you possibly can, because nobody gets out alive. And it's a pretty fun, when you're gone, you're gone. Okay, let's do a safety meeting. I think we have a really good safety meeting today, and I don't see any new participants. So let's get right into. Wow, are we week 9 already? Huh. Okay. So this is a favorite of mine, and actually this is the first time I've ever seen this. Particular safety sheet. All right, I'll start out, and then I'll pick some people to read for me. Construction music on work sites. Construction music on work sites. Introduction. Construction sites are loud places to work. Using radios or personal listening devices can add to the sound of the construction site. While music can be nice to listen to, and some employees may think that headphones can be substitutes for required hearing protection, listening to radios or personal listening devices can potentially expose employees to harm. Employees should always wear the appropriate hearing protection for the environment and task. Let's see who's here. Brenda, would you please read start with noise induced?
Noise-induced hearing loss. Headphones for personal listening devices are no substitute for OSHA-approved hearing protection and have the potential to contribute to noise-induced hearing loss. Noise-induced hearing loss can occur after an employee has been exposed to loud sounds repeatedly. Employees should not be exposed to 85 decibels for more than 8 hours. For tasks that exceed 85 decibels, the exposure time shortens.
Okay, how about you, Jose?
Well, listen, or distraction.
Oh, right here.
Oh, a personal listening device that is set to the max level can exceed 100 decibels. Those decibels combined with the decibels that occur from work being performed on a work site can potentially lead to noise-induced hearing loss. Noise-induced hearing loss is a permanent condition that cannot be reversed.
Rag. So Catherine's not here. Jose. Colby, would you please read distraction?
Yeah. Distraction. While listening to radios or personal listening devices can help make the day go by faster, they can be a distraction to everyone on the job site. Distractions can occur from trying to switch songs, tuning the volume up or down, trying to listen to an ad or a particular song over the noise of the environment, walking or working with headphones in and not being able to hear the sound of moving equipment.
Okay, next, please. Who's after Colby? Kevin.
Radios and personal listening.
Go to distractions. I don't think you read distractions.
Distractions can lead to accidents. Accidents that are caused because someone was distracted could not only involve the person who is listening to a radio or personal listening device, but coworkers who are working around you. We keep going.
Now go ahead. Communication.
Radios and personal listening devices can hinder communications on a work site. Communication on a work site is important because employees need to know who is doing what and any changes in working conditions. Employees who blast music from radios or have headphones for a personal listening device inserted into their ears cannot hear changes in instruction or the sounding of alarms or other warnings. The interruption in communication can result in an accident or worse.
I'm going to finish. Note, headphones made for personal listening devices should not be worn in the workplace unless authorized by your employer. And the conclusion, while radios and personal listening devices can help make the day go by quicker, they can potentially expose employees to harm by contributing to noise-induced hearing loss, being a distraction, or by hindering communication on the work site. Employees should wear only OSHA-approved hearing protection while on the work site. Okay, so would anyone like to comment on this safety topic? Because I sure do. I sure want to comment about it, and I'm going to. Are you ready? I think I'm gonna get over here first because we've seen this. We've seen hearing loss, distraction, right? All that stuff, all that good stuff. So let's go to stop share. All right, so I just want to get you all back and look at your faces and make sure John got back. But before we go back to screen sharing, pretty dog. Hey,
Excuse me, Rodney, you need to record.
He is recording.
Is it
yeah,
oh,
I'm
I'm
recording.
sorry. I'm sorry.
No, that's okay. Thank you for thinking of me, though. Hey, just something to radios on job sites. Now, headphones, I have opinions about those too, because when you are got music in your ears, you're not listening to what's going on the job site. You can't hear people shouting things at you or trying to get your attention for whatever reason, and it could be a really good reason. So in that case, I would prefer people not. My pet peeve as a contractor and an employer started when I would pull up to a job and there'd be like one job radio blaring, or maybe two cacophonously, two different stations, but I would try to have a conversation and talk over some radio or music. And I got really tired of that, and I got really irked about it. And so I have been known to roll up on a job site and kick a radio as far as I can possibly kick it and break it into 50 million pieces. And it kind of got around so that I would pull up to a job site, people would run to the radios to turn them off if they wanted to keep them. It's like, oh shit, here comes Rodney, turn off the radio. I can't stand radios on job sites. And so basically I couldn't control a job site that I wasn't on, but if I'm there, there's no radios. It's just, and you see some of the larger companies have big signs, no radios, no drugs, no dogs. Radios are just a distraction. Now, to finish with this whole radios on job site thing, if you're working by yourself, and let's say you're sanding or doing some mindless job, having a radio or headphones, go to it. It's a great way to go. When I'm sanding a bunch of stuff, belt sanding, I love to listen to the radio by myself. That's an exception. But when you're working on a job site with other people and communication is happening, and it always is happening, then please don't listen to the radio. And you're not going to be listening to it on my job site anyway. And John's been working for me. John and George, you guys don't listen to the radio, ever. And yet we have roofers that have their station on, and I'm letting that go. John hasn't seen me kick one radio, which is pretty good. So maybe I've gotten a whole lot better. But Before we go back to screen sharing, I'm going to, I thought I pinned myself. Huh, that's weird. Remove pin, but I wasn't pinned. Okay, I'm gonna pin myself because I want to show you something. There we go. Okay. So I like to draft, right? I like to sketch and then dimension, and I like to draw to scale. It's something I really enjoy doing. I like designing. It's how we design. You know, this is a door. Actually, there's a stainless steel welded frame for a door that got skinned at the piano house. But I draw by hand. I don't draw with CAD, which is computer-aided drafting. And I'm a little chagrined about that. And I have enough computer knowledge and enough knowledge about CAD where I could probably pick it up pretty easy. And then John, of course, you know, did some sexy CAD drawing on his Google SketchUp that made me feel like a complete idiot. Nah, just kidding. I am kidding about that. I didn't feel like a complete idiot, but I like to draw by hand. And it really makes me feel in touch with what I'm doing. And so I've been meaning to get a few more of my drafting tools upgraded because I have a black architectural scale rule that I hate because I can't read some of the smaller, you know, foot increments, inch increments. So I got myself a new aluminum. Yeah, aluminum rounded. Isn't that cool? I'm in love with it. Architectural scale. And I got myself a new electric eraser, which is so killer, and a new racing shield and all kinds of good stuff. So that's an erasing shield. That's my old one. So how erasing shields work is you put this over to cover your drawing. So you just, all those little things you can put over what you want to erase, and then you just go like, get it? Okay. Okay, good. Okay, music on job site. Here we are. Now let's go back to our modules. Let's go. So by the way, I noticed, here's the reason why I kind of switched up. I told you we were going to do Whole House this week and look at that really incredible project, that modern concrete and glass and steel house up on Campanile Hill. And we're going to do that next week because I noticed in the syllabus that Jim put together, and I just kind of tweaked as far as dates and got my name in there and stuff. But I noticed that this week, week 9, this week right here, was various subject. There was going to be a drywall demonstration last week. I don't know what happened to that. I guess I should keep up with this. But the insulation demo. So it's going to be a lecture on, I'm sorry, I will try to refer to this in the future. I've kind of forgotten about it, so I'm going to try to refer to it, but I'm referring to it now. That I wanted to pick up thermal and sound insulation for you, and which is what gave me the idea for today's lab. And today's lab is about a variety of things, but we're going to start out with, okay, we're going to start out with something, a couple of simple things like, I mentioned this waste repair that we had at the job I'm doing, where we had a mainline blockage under the slab, and we repiped the waste on one side of the building and on the other side of the building to leave the building and tie into new laterals. And I thought I'd just show you a little bit about it. All right, I'm back briefly. All right, I'm back briefly, and what I'm showing you here is some of the plumbing that we've repaired. Some of this stuff. Oh, yeah, look at that. That's right. And which one was this? Rudy? Ismail? That one. Was that the bathroom? Yes. So that's the tub. That's how corroded that pipe was. Yeah, we had to do some repairs here. We had to do some repair. Yeah, we had some corroded that pipe. Okay, look at that. You guys see that? That's a 2-inch pipe. That's a 2-inch waste pipe. Does it look like you got 2 inches of space there to get things through? Not quite. That's what happens to galvanized pipes. Yeah, we had to do some repairs here. We had a lot of badly plumbed and huge mainline blockage, which I told you about last week. And here's the new waste plumbing that we're doing from the laundry, picking up the kitchen sink, and then we'll be heading out. What did I just do? And here's the laundry. Yeah, that's going to be replumbed, all nice and new and tight, tested. And I'll take you into the house and show you what we're doing with the bathroom. Okay. Okay. We just had real substandard underfloor plumbing. We had a big blockage, so we had to do repairs. So when we got into it, we just went ahead and replumbed it. Sorry about the darkness. It was about light. So I'll take you out. I'm going to grab a light. Yeah, let's go in and just take a look. Here when it came out, it's going to go back in the hole. All right. Yeah, see that? Okay, try to remember that. Remember seeing that, because next week I'll show you what happened yesterday there when it got poured. Okay, you'll remember that hole, and what it looks like now is going to be completely different. All new plumbing. Vent stacks are all full. It's all holding water, which is fine. And it heads out, and then it'll pick up our new lateral, which will be new all the way to the street. So just to be clear on this new lateral thing, City and County of Santa Barbara are really big on when you pull a permit and they get a chance to look at your property. I'm not sure where the cutoff is, if it's the size or the square foot you're touching or the amount, but at one point they get to require you to, and in this case on the job we're doing on Chillum, the County of Santa Barbara required us to have the sewer line camera, sewer lateral. The sewer lateral is where it leaves the house, and there should be a clean out, mainline clean out, and then to camera it all the way to the street. And then they ascertain based on that film of the condition of your lateral, your sewer lateral to the street, they ascertain whether or not it's in the condition they feel is acceptable to leave it. And if they don't, in other words, if it's Orangeburg or Bermica, and Orangeburg is a clay pipe, Bermica is a asphalt impregnated paper, basically. They crush, they don't last. The clay pipe, the sections break, roots get in them. So we had old clay pipe there, and we were told that we had to do a new lateral. So we're going to do a new lateral. So from where the sewer leaves the house and heads towards the street to dive into the city sewer, that has to be a brand new lateral. And that's a problem for a lot of people, and it has been a big problem because typically to lay a sewer pipe underground, you have to dig relatively deep, and you have to dig all the way out to the street, and you have to dig through driveways and lawns and rocks and hardscape and landscape features and all that stuff, and tell about 10 or 15 years ago, maybe 20 years ago, they came up with this bursting technology where they burst pipes. It's a trenchless, sewer pipe. They don't have to dig a trench. They have to dig one hole at one end and one hole at the other end. And they set up a machine down in this hole with a backboard, and they burst your existing sewer pipe. They go through and they actually burst out the pipe, and they sleeve in a brand new pipe by bursting the old pipe. It's a pretty cool way to go, trenchless. So we'll be able to do that for a while. We have to do some trenching. When we do that, I'll still be doing this class. So I'll show you what we're doing when we finally open up that, get rid of the driveway, and we run a new trench down for a new water and gas line down the side of the house, and we run a new lateral from the laundry, pick up the kitchen sink, and then we tie across and tie into the new sewer laterals that leaves the house from that side of the house, the east side, and then as it goes and ties the street. I find it really fascinating because it's one of those things that the pipes are buried. It's like again, flipping a switch, it's like magic. The lights come on, flush the toilet like magic. It all goes away. But it's not really magic, is it? No, it's not. So let's go back to sharing. Okay, so insulation. Let's take a look at Mangone's insulation. Well, hello. It's Rodney, and I know there was a bit of a delay there because I was trying to get the lens cap open. But we're back in the Mangone job, and I noticed that in the syllabus that we have a section, and I think it was last week, about insulation, thermal protection and insulation. And so I'm gonna just briefly show you the insulation part of this job. It just got insulated. Behind this wall, this is shear wall on the inside. And if you ask me about it, I'll tell you about shear wall and the significance of it. It's a specific thing, sheared walls. Because it's on the inside, we had to insulate from the outside and then sheet. But here's our unfaced bats, R13, might be R15, that we can do. And actually, yeah, that we can do. And you'll find out in a video a little later from David James, the difference between R13 and R15. This is definitely R13, not R15. Virtually any wall. We did a 3.5-inch rigid insulation on the roof here for a vaulted ceiling. You can see the rigid up in there. This ceiling's vaulted with 3.5 inches of rigid insulation on top, furred out, and then you see the rigid insulation there. And then we exercised an option and did a unfaced bat installation in all of our interior walls, which I recommend it always as an option because it's cheap for what you get. You get sound transfer, sound dampening, and you get just a warmer and cooler home when it's needed. So here's all our unfaced bats. This is attic ceiling, crawl space accessed attic ceiling is all batted. These exterior walls are all batted. We took off, this was a patch. And again, you're going to hear about this with David James, but the difference between conditioned and unconditioned. So a question I've heard a lot is that why do we insulate the ceiling joists in an attic? Why don't we insulate the roof? Well, because we don't want to make the attic conditioned space, because it's not conditioned space. We don't want to condition the space. We're conditioning the ceiling below the attic. The attic is unconditioned. Now, if you isonine the rafters, which people do, then you've created a conditioned attic, which in some cases people will argue is a better way to go. But for right now, we're conditioning the living parts of the house and not the attic spaces, which are not living parts of the house. We took our drywall here to expose the And I had all kinds of walls that had existing drywall on them, and we were meant to leave the drywall and just patch it, because we were just changing out windows, taking old windows out, putting new windows in a lot of cases in the same size hole. So we just had drywall patching. But once we had those windows out and we had opened up a couple of areas for whatever reasons, realized that for at 100 square feet of drywall, we could take off the rest of the drywall on that exterior east wall in these 2 bedrooms and be able to expose the walls and put insulation into uninsulated walls that would remain uninsulated if we didn't remove that drywall. So we opted, drywall at 65 cents a square foot, 100 square feet is $65. It's worth it to be able to get insulation in those walls, especially exterior walls. Interior, so we could get insulation on those walls. Bathroom insulated, closet insulated, bedroom completely insulated. And of course, the ceiling above us is insulated. There's just a bit of a patchwork to be done there, but you can see the insulation in the ceiling, and you see the insulation nice and tight around all the walls, and all the spaces around the windows and doors are foamed with an open cell foam insulation, so no air can get through there. Now let's go see some of the interesting parts, like the isonine or open cell foam. It goes into 2 parts, and then it foams out and hardens, and it's screeded or scraped in some cases, so it's not proud of the ceiling joists. But or rafters in this case, because we have a vaulted ceiling, rafters, and then a roof above with no insulation, we can insulate down here and not have to insulate the rafter base. So this is what isonine looks like. This is our, I think I breathed some sawdust. These are our foam around our doors. All our openings are foamed. All our insulation is nice and tight, and all the stud base. This is another stud wall. Another shear wall. They get shear panel, and then insulation on this side, and then into the master. Let's look at the master bath. Skylight well is all insulated. Bath walls, interior walls insulated. Like I said, we opted for that option. I know you probably can't see in here. That's a niche for the master shower. And now here's our other piece of isonine. Well, we have a vaulted ceiling, and if we hadn't done it, if we hadn't insulated like this, and we'd done a regular batt insulation, we would have had to vent at the ridge and vent at the eave every rafter bay for air movement. And we don't have to do that. That's kind of a hassle, and just creating more holes in the building to let stuff in by using this isonine material, which is an open cell foam. And it does the job, I'm telling you. This sound dampening is done so well in here. Here's that wired smoke detector we moved for the inspector because he saw it was closer than 3 feet to that register. It's been done. Okay, so you've seen the insulation. I'm going to just walk you to the last place you can see some insulation. See it here in the garage. That's the utility room wall. There's the contiguous wall to the office garage. We've got bad insulation up in this attic, which gets a fire rated door to access it. And then we'll go out and walk over to the utility room, which now has doors on it, which is fantastic. I love it. And they're locked, of course. And there's a key somewhere. Okay. I want to show you the inside of that utility room. So then I can say I've shown you every part that's been insulated. Oh, darn it. Okay, key's down here. So suffice to say, it's insulated, and because it's a vaulted lid, it's also isonine. I may show it to you. And I'm not going to be able to show it to you. That's okay. But what I am going to be able to show you is David James. So, hey, it's Rodney, your CT 111 instructor for your lab component of the class. I'm here in David James's office, a company that he's the founder and CEO of. Is that correct, Dave?
That is correct.
Insulate Santa Barbara. And we're going to be talking to Dave for a bit. We're going to tour his facilities and talk about insulation and thermal protection. I guess that's it, right? That's the name of the game. So, Dave, could you please introduce yourself and just tell us a little bit about yourself and how you got into this business and what you do?
Okay. So I got into business through my father, Ken James, who was a drywall, lathing, plastering contractor in the 1960s here in Goleta. And towards the end of the 60s, when insulation started becoming a requirement on some projects here in Santa Barbara, my father found himself in a position where the insulation contractors were holding up his projects. So he became an insulation contractor. In about 1968, that was kind of my first experience with fiberglass and unloading truckloads and things like that. Fast forward to about 1974, that's when my father became an insulation contractor 100%. And I started with him doing some small projects. I remember the first time that I got involved with doing a blown insulation project. I was feeding the hopper, and the guy that was working in the attic, he decides that it's my first day to learn how to do blown insulation, crawling up into an attic. So he hands me the hose and says, just go for it. You know, it's just like watering a lawn. And so I get up there and I'm trying to put in 2 inches of insulation in the attic. That's the requirement back then, which was hardly anything. So I'm basically running through the attic and I end up stepping through the ceiling. First house, you know. And it happened to be one of those, 1x1 panelized sound ceilings that are expensive to patch. Well, I heard a little bit of that from my father at the end of the day. So I just kept working with my father, learning the trade. And in about 1978, we started another company called Santa Barbara Insulation with me, my father, and 2 other partners.
Were you still doing hung ceilings? Was Kenny, did you ever do hung ceilings?
No drop ceilings.
You pretty much just got into it doing the insulation.
Insulation. Well, it was in 1976 that insulation started becoming a code requirement for residential. And so in 1977, 78, they had an amazing shortage of insulation. And
tell us about that, but before we interrupt you, so I want you to finish your bio, get us up to date, and then if you wouldn't mind, help me remember, go back and tell us the principles of what you do too, like why we're doing it. But before that, let's finish your bio.
Yeah, a little bit more about me. So 78, we started that company. Fast forward in 1985, I purchased the business from my father and groveled through the 1980s, barely making it, pretty much not making it. Coming to the 90s, pulled it together and did pretty well. I ended up selling the company in the year 2001 to a major corporation. National, yeah, Masco Corporation. Yeah. And stayed on with them for about 10 years and then started this company, Insulate SB, in 2011 and built it up to where we are today. And we specialize in custom homes. Spray foam technology is our real winner. We've kind of promoted that product throughout Southern California. And we cover areas from San Simeon down to Laguna Beach. Reasons we want to insulate. We basically are looking at a home a building that's trying to equalize the temperature and the air pressure between the inside and the outside consistently. So whatever the temperature variance is outside is trying to equalize that into the inside of the building. And if it's windy outside, that wind's trying to get inside. If it's humid outside, it's trying to get inside. If it's dry outside, it's trying to get inside. And we're trying to create an environment that's comfortable for people to live year-round, so they don't really have to think about turning the heater on, the AC on, or being uncomfortable in general. Codes have followed the requirements of controlling certain temperatures based on the energy consumption and energy costs. So when we first started out, it was R11 in the walls and R19 in the ceilings. And today we're seeing projects with R60 in the ceilings and R50 in the walls.
Stop for just a second there. So, and that's on purpose.
Well, there's reasons behind that. Specifically windows. Windows there's a mathematical formula that allows a person to put in more glazing if they have more insulation. Now, the numbers work on math, but in actual field conditions, it doesn't really work. I mean, glass is glass. The best glass in the world really is an R8 value.
Yeah.
And that's triple pane.
Okay, wait a second. Now, even triple pane only gets you R8.
About R8.
Surely.
Maybe with some argon gas. I mean, I don't think
So
I've
right
seen but
now-
one project with triple pane glass.
But so right now, the max double pane, say quarter,
Mhm.
3/4 spacer would give you R8. Max out R8.
I don't think it's that high.
Wow.
Yeah.
And then what you've got is you've got a coefficient for the fenestration of the house.
Mhm.
So you can have so much square footage of the house, percentage of the house
Mhm.
in glass. And if you go over that, then you have to increase the insulation. And the walls don't have.
Well, there's some variables with that. I mean, if you add in solar, you get some advantage points for solar. If you have a tankless water system, you can get some benefit from that. If you have a high efficiency furnace, you get benefits from that.
All these things would contribute to you being able to have more glass than the
Mhm.
code allows based on square footage of the project.
Mhm.
You get a little bit more glass area for on-demand water heater, a little bit for isocene foam, right, for close-up foam.
Well, not so much.
Open zone.
No, it's so much for the foam. I mean, there's some advantages to a conditioned attic where you're conditioning the roof assembly instead of the floor assembly of the attic. And if your duct system happens to be inside the attic, now we're keeping the ducts in a conditioned space, which gives you an added advantage.
So, tell us about conditioned versus
Mhm.
unconditioned spaces, because that's like key
Mhm.
in your job, right?
Well, we look at a house typically has an attached garage. The garage typically is unconditioned. That doesn't mean we wouldn't want to insulate the roof assembly of the garage, but the unconditioned space means that we're not providing any heat or cooling to condition that particular space. Whereas the house, we're trying to keep it at a specific temperature through the introduction of heat or cooling. And that pulls in the code requirements for us to have to insulate.
Hmm.
Mhm.
And so where has insulation gone from R13? Is it still R13 on the 3.5-inch wall?
For existing structures, R13 is still applicable for existing structures. We have a 2x4 stud.
Is that the max you can get in a 2x4 stud, is R13?
No, with bad insulation, we can get an R15 with fiberglass material or walkable material. We get an R15 and a 2x4 stud, but the cost of that material is the same as R30. So you don't want to go there if you can work around it.
Wow, so an R15 is the same cost as an R30, just because it's designed to fit in the 3.5-inch wall, I guess.
Well, it's basically a very thick material compressed down to 3.5-inch material. Hence, the weight of the material is similar to an R30. So they basically look at the poundage of the material and base that on the cost.
How has your jobs changed from when you started doing it in '68, unloading trucks and your debts, and you started putting bats in walls and stapling? They're all paperback, right? And you had flams that you stapled inside stud bay.
Yeah, that was pretty typical to see a vapor barrier on the insulation itself. And some of our contractors, they love foil-faced material because it looked pretty, made them look good. Owners loved it. But we fast forward to portable phones, cell phones or home phones. They found that the foil facing on the insulation caused interference with the portable phones. So we pretty much stopped using that basically in the kind of mid 90s. That kind of went away. Vapor barriers are really not a true vapor barrier because it's not sealed. It's a misnomer, I think. I think the only way you get a true vapor barrier is a monolithic covering which is overlapped and taped, plastic, for example. But different environments, different locations around the country require a vapor barrier or not a vapor barrier. And it could be on the outside of the building or the inside of the building, depending on the amount of humidity in the air or lack of humidity. So we typically use unfaced material. And part of that goes back to code officials in their striving to do the best that they can. Went to the online videos that were available to them through the California websites, and they showed where vapor barriers were installed that they had to face staple the flanges onto the face of the studs. Now, this application caused total havoc for the drywallers. When we first started doing this, drywallers were putting a hit out on my life. Seriously, they were very, very upset. And building officials were having a difficult time with looking at projects that had, let's say, less than 16-inch on center framing. We couldn't face staple both sides because it was cut to, say, 11 inches, and you had to cut it down. So it went away pretty quickly using the face material.
So when you say face staple, I want to make sure, and I'll probably explain this to them when I show this video, but so that at the end of the back, which has got paper across one face,
sides of the back.
It's a little tab on either side.
Mm-hmm.
That would go over the face of the stud, and it's perfect as 14.5-inch stud bays that lay over and staple, right?
Yes.
And from both sides.
Mm-hmm.
But yeah, anything less, you're only going to get one. They didn't require you to tape it or anything like that.
Yeah, they didn't show any requirements for taping, but
So how, that's one way I know it's changed. But what about pricing? Because well, we've seen everything go up in price, but just thinking about what insulation costs, like you know of back in the 70s, what that insulation costs versus today, how does it compare?
You know, as far as the cost of other items, it hasn't followed the same suit. And part of that is
other building materials, concrete,
maybe not building materials, but maybe like food products or clothing products, other products that I'm aware of. It hasn't gone up that much, but what has really changed is the application of how they're packaging the material. In the 70s, everything was paper-faced. The wrapping of the bag was paper-faced. There were individual bags. And fiberglass can compress down to a very small amount of space, considering how much comes out of a bag. A typical bag is, 100 square feet, and it's 1.5 by 1.5 by 4 foot long, and 100 square feet of 6-inch material.
That's 10 cubic feet.
Yeah,
becomes 100 square feet.
Absolutely. So what they started doing was they changed from paper-faced to plastic. And when they first started doing that made a huge difference. And then they started shrink wrapping straps around the bags themselves. So we went from individual bags to a 4-pack. And then they went to a 5-pack, which was the same space as the 4 bags that was compressed.
Is this John's Manville? Is that pretty
all
much?
manufacturers? Yeah, all manufacturers. The first insulation plant that I went to was in 1978, and it was at Chowchilla. It was a Certainty plant, brand new. They had, at that time, I think, 58 employees. I went back in, I think it was 1986, and they had, I think, 12 employees. Everything was automated.
Oh, yeah.
Unbelievable. And the same happened on another plant that I went to up in Willows for John's Manville. It was just amazing how much technology had changed in their ability to package everything using mechanical equipment versus labor or handheld labor.
Yeah, and they're making the same thing and lots of it. Perfect candidate for robotics and CNC control.
Well, one of the things that did change a lot during that time period is going from the use of sand to recycled bottles.
This is to make the glass.
To make the fiberglass. Yeah, the percentage is roughly around 40% of the fiberglass material is all recycled glass.
Okay, so
Billions of pounds.
tell us about that, because I bet nobody even knows.
Mhm.
How do you get the material you're calling fiberglass?
Mhm.
And then after you tell us about that, I want to remind you to talk about rock wool and stuff like that. But fiberglass, that's the most used
Common.
material, most common material for insulation, craft backed or not, or unfaced. And what the heck? What is it? What is it? Where's it come from?
Well, silica sand is the main component in the product.
Just like glass.
Yes, just like glass. And they put in a couple of little special things. They don't really tell us exactly what it is. But the two plants that I've gone to, the line is about 300 yards long. Yeah, it's an amazing process where they start in a large box, basically with a spinner that looks like a colander, and they pour molten glass, which is, I mean, you barely look.
We're gonna break until, I was gonna say 10, yeah, let's break till 10:25. See you back here, 10:25.
All right.
Hey, sorry I didn't get back to you yesterday. I had a really insane day yesterday in every way. So, I'm doing class now. I'm just having a break. I'll be back at 10:25 with the class. God, it's cold here. So, I'll be there after 12. Okay, later. Bye. Hey, Pat. Yeah, I'm on a break. What's happening? You called me yesterday and I couldn't get back to you. No, I didn't know that. All right. So what's happening? Is that what you called? Talk about now? I want to look at that stuff. You know, I think we have to plan that. But really, I mean, it's nice that we're integrating, you know, the career center and her thing, because we want these people to find jobs. So it's great. Yeah, I think that was it, unless it was something, you know, something you guys talked about. Right, right. Yeah. All right. Yeah. Yeah. Friday. Friday. Yeah. 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 Monica. Yeah, yeah. I haven't done one, and I don't think I will do one, but yeah, send me yours, and then if it's brief enough, I'll just do that. Yeah. Right. Right. Yeah. Yeah. Uh-huh. Mm-hmm. Oh, what a good idea, man. What a great idea. Yeah, send me anything you got. I gotta get back. I gotta fire this guy back up. Otherwise, you're good. Okay. I hope I'm good too. Right, later. Thanks. Bye. it's cold in here.
You were always so cold, Rodney.
I'm old. My blood's thin. I don't have much fat on me anymore. Fat keeps you warm. Just ask any seal or whale. It's the blubber. Yeah, I am cold a lot. You have no idea. But this classroom is freezing. It's like an ice box. And then the heater is, I don't know. I don't like the sound of it. Plus, it's kind of a weird heat. All right.
It'll-
So
it'll-
Colby, Jose, Josh, Kevin, come on back. You guys, Josh, Colby, Jose, I want to see their faces. There's Josh, there's Colby.
Hello.
Hey, how about Jose? Jose, you around? Not Jose Landeros, I can see you. Jose Silva Nunez, did you come back? It's Kevin, there's the jerseys, Kevin's jersey wall. Jose Silva Nunez? I don't, it doesn't look like anybody joined that I have on my roll. I can't see anybody. Dario, Donna, Mondo, Emmanuel, D'Angelo, Aurelio? No. Okay, there's Jose. All right, so let's get right back. I'm gonna there's gonna be chances for you guys to ask questions. Let's do one more Dave of the four, actually five is just a couple seconds just to say bye. Let's do one more Dave, and then I'm gonna show you what I consider to be a super interesting video.
Got it first. Second, it's like looking into the sun. And it pours the molten glass into this, it's like looking into the sun. And it pours the molten glass into this colander that's going back and forth. And the glass is, the whole thing is kind of moving together. And it's spinning cotton candy. It's basically what it looks like.
Fibers of.
And it goes down into a big conveyor belt that's about, I want to say it was about 10 foot wide, maybe 12 foot wide. And they, depending on what R value that they were doing, it would spin it towards maybe 24 inches in depth to get a 10-inch material, for example. It was really light and full fluffy. So then it would go through this conveyor line where it would go through a drying process and a compression process. And once it got down to about 200 yards through that process, they were able to cut the material in widths, and they would trim off the excess edges, and they would use all the excess trimming for blown insulation. They don't throw it away. They save everything.
I think it goes back in the pot and get melted down, but why not use it for?
Yeah, the Chowchilla plant, I think, had somewhere around a $10 million filtration system, so that they filtered all of the glass in the air, and they reran it through a pug mill, basically like a pug mill, and took all of the glass and then recycled it again. So all the fibers that got into the air, they were able to recycle them and run them through again.
That's pretty great.
It's a pretty amazing process.
And so fiberglass is basically a renewable resource because
Somewhat.
I mean, is silica sand being made now?
Well, I was reading.
Is the earth, is nature making silica sand?
It is, and I was reading an article a couple weeks ago that sand is disappearing from our coastlines because with all the dams that have sealed up all the major rivers, so we're not getting that flow of silt into the oceans. Like we go down to Mexico any time of the year when it's raining, and you fly overhead and you have these big plumes of sand going out in the ocean, or dirt, whatever.
Particulate matter, dirt, the earth washed down, and which eventually becomes sand. It's got to be rocks, right?
Well, like
rocks and shell.
Like in Hawaii, you have coral, where the fish are eating the coral and pooping it out, and that becomes the sand. It's pretty cool there. But this
we can't use coral sand.
no.
That's not right. It's got to be silica sand.
I don't think there's enough coral sand to create the amount of
Where
product
do
that
we
we
get
have.
the sand?
You know, that's a good question. Don't know.
Because basically what we're talking about is the stuff that you, besides icing,
Mhm.
that insulation of the foundation of the insulation trade as we know it.
I'm going to come back to Dave, but I want to jump in here with this. I found this extremely interesting. It's not very good resolution, but it's a very cool video.
Birds have feathers to help keep them cool in summer, warm in winter. It's their insulation. Animals have fur. Both feathers and fur have millions of tiny air pockets to help keep out heat and cold. Natural insulation. When it comes to people, most of us depend on fiberglass insulation, and nobody makes higher quality insulation than CertainTeed. Closely mimicking nature, fiberglass insulation has millions of tiny air pockets that help reduce the flow of heat. This remarkable material comes in two basic forms: bats and rolls made to fit between joists and studs in ceilings and walls, and blowing insulation. This is CertainTeed InsulSafe insulation being used to insulate an attic. It all starts with sand. From sand and other ingredients, glass is made. Recycled glass called cullet is included in the formula. At plants like this across the United States, CertainTeed Corporation manufactures fiberglass insulation to exacting specifications for use in thousands upon thousands of buildings and homes, just like those you work and live in.
This could very well be the Chowchilla factory that David said he toured. That's Chowchilla. They never did spell it right on the captioning on YouTube, but it's CHOWCHILLA, Chowchilla. And that could have a 300-foot long product line. Looks exactly like what it is.
The process begins with raw materials arriving at the plant by rail and truck. Every step of the manufacturing process is completely automated. At the batch house, where raw materials are received and transported to enormous storage silos, ingredients are precisely weighed and mixed to an exact formula, then transported to the plant's melting furnace, where the batch is fed into the furnace. In the furnace, the dry ingredients are heated to approximately 2,500 degrees Fahrenheit and gradually added to the contents of the furnace, 400,000 pounds of red, glowing, molten glass. Now watch as CertainTeed's advanced fiberglass technology transforms molten glass into fiberglass insulation. Below the furnace, liquid glass flows into a series of fiberizing machines, where in a single operation it is spun with tremendous force, cooled, drawn into thin glass fibers, and sprayed with a binder which will hold the fibers together in the finished product. As the fibers collect on a conveyor, they build up into a continuous mat of insulation, which later down the production line will be cut into lengths and packaged into bats and rolls. Another separate series of fiberizing machines produce InsulSafe, CertainTeed's premier blowing insulation. To give you an idea of the size and complexity of this operation, just look at the sophisticated control room. The storage tanks containing liquid binder. The operation incorporates pollution control equipment to protect the environment. A great deal of water is used in the process, and all of it is cleaned and recycled. Glass fibers are removed and recycled also. As the mat of fiberglass moves down the conveyor, it passes through an oven which cures and dries it. The thickness and density of the insulation is controlled by regulating the conveyor's speed. Here, the large blanket of fiberglass is cut into bats and rolls. This production run is R19, an industry rating indicating the material's resistance to heat flow. The thicker the insulation, the greater its resistance to heat flow. Some of the insulation is made with a vapor barrier attached. In this case, craft facing is bonded to the fiberglass with liquid asphalt. Virtually every step in the finishing and packaging process is automated. In a single day, the production from this plant alone is enough to insulate over 250 average-sized homes. In one continuous operation, from sand to glass to fiberglass, CertainTeed produces this economical, efficient insulation that helps keep millions of homes and buildings cooler in summer, warmer in winter, quieter year-round. Insulation that is easy to work with and affordable, and that helps keep fuel bills lower and saves precious fuel. Without fiberglass insulation, what a different world we live in.
At it for a second. It's like looking into the sun. And it pours the molten glass into this colander that's going back and forth, and the glass is the what we put in a bulk water scenario. Whereas closed cell,
Is it thicker? Is it a better R rating?
it should be all underneath the Huntsman name. Not sure.
The logistics problems that all of us in construction have. We can't use coral sand.
No.
That's it, right? It's gotta be silica sand.
I don't think there's enough coral sand to create the amount of product
Where do
that
we
we
get
have.
the sand?
You know, that's a good question. Don't know.
Because basically what we're talking about is stuff that you, besides ice, that insulation and the foundation of the insulation trade as we know it, it's from a product that's made out of sand. I'm so curious to find out where that happens. So maybe this thing airs on Saturday, we'll have an answer for where the sand is mined and how it gets to these plants.
Well, they get them all by rail.
Okay.
And they pump it in, they just pump it in, including the recycled glass.
And to make glass out of sand, it's a process of mixing it with something and heating it up.
Heat it up, yeah. It takes a lot of energy to create it.
It's all of it very interesting physically, just to get to that place. But to get to that place where it's a manufactured product, I'm so jealous in some ways because, I mean, even though you have different applications and different houses and different customers and different, you have all the logistics problems that all of us in construction have, including timing and working with other people, but you are working with one thing, and various thicknesses.
Make
And
it
if
sound
you-
so easy.
I know, it's so simple. It's so easy for you. What, tell us about ice cream. What's the deal with, and it's cell foam, right?
Well, Icynene is a name brand, which is probably going to be going away.
And it's Icynene, so it's Icynene. Icynene. They keep spelling it icing. It's Icynene.
Because Huntsman, who happens to be a large chemical manufacturer in Texas, they purchased Demolac, Lapola, and Icynene brands. So they're all underneath the Huntsman label now, and they're probably going to rename or rebrand the brands themselves to be all underneath the Huntsman name. Not sure what names they're going to come up with, but Icynene, for example, has changed their product names, it seems like about every 3 years. Icynene, it was a Canadian company, started in about 1986, and they developed an open cell foam instead of a closed cell foam, which took quite a few years to kind of get out in the market.
What's the difference?
Well, open versus closed cell. So 90% of the cells in closed cell foam are closed. In other words, they're sealed, and they use a gas to create this air pockets in the material. Whereas the open cell foam is more than 90% open cell foam, and they use it's more of a water-based chemical reaction than a gas that could create these closed cells.
But it does the trick. And so how do they differ? How do they differ? How does the closed cell foam differ? Because you have a closed cell foam insulation too, right?
Correct.
How does that differ from the open cell foam in terms of everything? Is it thicker? Is it a better R rating? I know it's more expensive, right?
Yeah, definitely. So you have two products, your open and close. They're both capable of being used in any climate, all the way up to Alaska. The challenge with open cell foams is that it allows moisture to go through it a lot easier, and it will absorb bulk water, even though it's hydrophobic. So in other words, you can put it on top of float it on top of water, and it'll float there indefinitely.
Is that what hydrophobic means?
It's afraid of water.
Okay.
Hydrophobic. Yeah.
Well, it doesn't.
It's not like a sponge. But that being said, if you submerge that same product underwater and hold it there, it will absorb water like a sponge. So that's what when we talk about bulk water, we don't want to put in a bulk water scenario. Whereas closed cell, we can put it underwater and it won't absorb much water at all outside of the 10% of open cells that are on the outside of the foam itself.
What about insulation value, R value?
So our values with open cell typically are 3.7 per inch for what's called half pound spray foam. They do make a 3/4 pound spray foam, which has an R value of 4.2 per inch. Gives us a little bit of added advantage for those projects with a 2x8 rafter where we need to get an R30. We can get an R30 with the 3/4 pound foam at a less expensive cost. Closed cell foam, roughly nowadays, since it has an HFO, so it has no fluorocarbons in it, has an R value of 6.8 per inch, depending on the manufacturer.
And then how about cost wise? Is it double?
It's about double. It's about double the cost. And part of the challenges of using either of the products is we want to use a product that will fit the requirements for the specific project. In other words, we want to look at what the Tile 24 report calls out for. Let's say, for example, it calls out for R60. Well, that's pretty beefy. For closed cell foam, we need a 2x10. Not too many people build past 2x10s. I mean, sometimes 2x12s, 11/7/8, maybe 14 inch, but R60 is pretty beefy. So we typically would only use closed cell foam for an R60 value and a 2x10. And that's the only choice we have.
Why would they call out an R60 value?
Well, again, we go back to the fenestration. If it has an excessive amount of fenestration, maybe it's kind of a give or take. Like I'm looking at 2 projects right now that are down in the Malibu area, and they have a lot of block. And they're able to get away with a low R value in the block of an R10. But they have to make up for that low R value in the block walls by going with, say, R31 on the walls that are framed, and then an R60 in the roof assembly. Might have skylights. Skylights can really hurt, but there's a balance there where you have an architectural piece of artwork. You want to build this cool project, but you got to insulate and it's got to meet the codes. Title 24 engineers are challenged by some of the requirements of these complicated houses.
To say the least.
Yes, and you know, between the general contractor, Rodney here, for example, insulation contractor, we pretty much pull together all of the missing links that the architect, the structural engineer, the Title 24 engineer, and other engineers didn't happen to take the time to talk about and work through the weaknesses of the system itself. So we both deserve a good pat on the back.
And you need a big picture.
Oh, yeah, well, I have the one in the front of the office. Yeah, we got it. I won an award for that.
Of course you did. That's what I'm saying.
Mhm.
You won an award and you got some value.
We actually have some new prints coming out on the new metal back pictures,
Yeah,
the
yeah.
really thin ones.
Oh, yeah.
Yeah, we ordered some
Oh,
of
yeah.
some of our projects.
You know, I'd love to see that. So, I find what we've been talking about so unbelievably interesting because it's become a vital part of construction.
Mhm.
It's become a mandated part of construction, and it's also a makes common sense part of construction to me.
Mhm.
For instance, when we have an opportunity, patching in windows in a remodel we're doing,
Right.
you know, extensive amount of work, and there's X amount of drywall left over. Let's take that drywall off. Let's incur the cost per square for new drywall so we can insulate the wall because it's a better wall. It's
Absolutely.
better for sound, better for heat and cold transfers. It's a better house. It performs better.
Well, especially in a house where you're going to come in and do a little bit of rewiring, and you're going to poke a bunch of holes in the wall, and then the taper's going to come out, and the drywall man is going to go, you might as well just pull all the drywall because it's going to cost the same. And when you think about trying to insulate an existing wall with blown insulation, you're limited on only doing the cavities that are large enough for us to be able to pump the insulation into those cavities. If you have a cavity wall that has a 1 inch or 2 inch opening, there's no way for us to get any product in there. So you have an 85% of the wall will get insulated, whereas 15% won't.
And I think, Dave, what you're to qualify what he's saying about blown insulation, I'm going to close your mic here, is that if you have uninsulated walls, you know they're uninsulated, you can go and locate stud bays, poke a hole, and blow in insulation to fill up that stud cavity, hoping there isn't a big block.
We check for that.
Above and below that, right? And then just patch the holes. So that's something you guys also do. You blow insulation into existing walls.
We used to. We now sub that out to another subcontractor, insulation contractor, because he specializes in it.
Plus wants to do that.
Yeah, it's well, you work with a lot of homeowners, and homeowners they're hard to make happy.
But it's a way to insulate your walls that aren't insulated, sure, tearing off that interior or exterior finishes. I also suspect that it's more common that people have their attics blown because of all the wiring and pipes and attics. It's much easier just to fill that thing full of insulation rather than try to cut bats. Is that correct?
That's a good question, and I think really what we want to focus on first for existing homes or any homes, you want to work on the ceiling first, then the floor, and then the walls.
Yeah.
And a lot of people tell me, well, my attic's already done, it's fine, there's no problem. What we've learned over the years of insulating existing homes is that the floor of the attic has lots of penetrations in it from wiring, plumbing, framing, drywall that's kind of pulled away from the studs, or the studs are pulled away from the drywall. The crawl hole cover has no insulation, it has no seal on it. So what ends up happening is we're providing all this heat on a cold day into the house, and the warm air kind of fills up the room and it's pushed up to the ceiling. If it can leak into the attic space where there's open vents that are drawing the air out of the house, it works like a stack effect. It just draws the air out of the house into the attic and out the vents. And it can go through multiple locations, through the plumbing, electrical lines in the interior walls, exterior walls. and go through the crawl hole cover. That's probably the worst one of all, is the crawl hole cover. So when people tell me that their house is insulated correctly, have somebody go and look at it, because most homes have had some tradesman up in the attic transferring, traipsing around the attic floor, moving material out of the way, and conveniently almost never putting it back. So you have all these holes that become the weakest link in trying to control this. Imagine yourself sleeping on a cold night and you pull the covers up and one of your toes sticks out. One toe, you feel that toe. Same scenario.
That's a good analogy. So we bring into play the second law of thermodynamics, which is heat seeks cold.
Yes.
Heat rises, heat seeks cold.
Wet equals dry, wet seeks dry.
And then, Dave, the types of insulation. We're going to cover batt insulation, which is generally fiberglass, but not always fiberglass. The isonine product, which are mostly like what I have at the Mangones, is a half-pound open cell.
Open cell, right?
Spray foam. And then what other types of insulation are there?
Well, we did used to have a product called Bonded Logic, and effective, I think the 17th of February, 2021, they are no longer producing Bonded Logic, which was the cotton insulation of choice. We found this product, I found it first in about year 2000 in a Las Vegas convention for the Insulation Contractors Association of America. And it was the best product I'd seen ever of all the cotton products I'd used in the past. But they're gone. Now it's a recycle. Now they call it a recycled jeans, but basically what it is, it's basically all the trimmings left over. To give you the idea that they're recycling old jeans. It's not the case. It's just trimmings.
It's recycled denim.
And they're coming from all over the world. It has a huge carbon footprint. They had some challenges with some water issues. It's not hydrophobic like a fiberglass or a spray foam. Yeah, so it absorbs it. But it's a feel-good product. They did a remarkable job marketing the product by putting a couple of the pieces of insulation on the floor with a baby on top of them. I mean, brilliant. They used a sound ASTM test method that was for an exposed application that made it look really good. Nobody leaves their insulation exposed. I mean, almost never. So they were smart. So the other products there's a product called Havelock, and that's a wool insulation that's coming out of New Zealand and Australia. I have had the chance of seeing this product. I'm not at this point sold on it, but I think there's a product for everybody out there.
Is it cost effective?
No, it's 4 times the
That's
cost.
also extremely green and extremely renewable.
Yes.
Wool.
Yes.
And so what about blown wool, rock wool? What's that?
Well, rock wool is one of the granddaddies of the insulation industry. It's been around since I believe the 1920s, and it's after they remove the steel out of the rock, they're left with this material called slag, and they do the same process like fiberglass. They heat it up and spin it. It just doesn't spin as fine. It's heavier.
So it's a product. It's a slag product from the smelting of ore to get steel.
Yes.
And then they turn that slag into this blown wool.
Into the rock wool.
Rock wool.
You've been breathing some rock wool, haven't you?
It's really rock. It's really rock.
Yes.
There's nothing cheap like about it.
No, not at all. And it's great for low frequency sound absorption. It's dense. There's not much footage in a bag. It's expensive and it's pretty hard to get right now. All insulation products, including spray foam, are very severely shortage in the next few months.
Is that due to COVID and supply chain
Texas,
interruptions? Things like that?
Texas freezing.
Because of what?
Texas freezing.
Texas.
Texas is the numero
Texas is a
uno
big problem.
location of spray foam product manufacturing.
Wow.
The number one. Yeah.
That would hurt.
And they, all their
Because you
plants
won't
froze.
feel it. The problem is not a problem, is that something that went down, that shut Texas down for a week, 2 weeks, a month,
Yeah.
you know, takes a while for
Oh, yeah.
people to, because they've got stock until they
Mhm.
don't.
So I'm really happy I don't have any big projects right now.
Yeah, that's good.
Because yeah, could be a problem.
Like I was saying, that I find this so interesting because of the whole idea of keeping places more comfortable, right? Interior conditioned spaces. The idea that what you're doing contributes to the comfort of the place, comfort of the home, comfort of the living environment. So we can stick around if we like 68 to 70 degrees, we can try to keep that, right? We can keep from leaks and the air transfer, stuff getting in that we don't want. We can even create negative pressure, right? Or positive pressure in the house so that air actually blows out from the window, right? Is that ideal now? Is that what we're trying to do? Because also now we're trying to bring fresh air, but you're in on all this stuff, right? This is a really great spot to be. And the physical properties, just the fact that everybody that's listening to this has probably got fiberglass insulation in the walls. And do any of them know that it comes from sand? Do any of them know where that sand comes from? I don't think so. So we're going to find out where it comes from. But I find that's incredibly interesting. And right now, we're going to get up with Dave. We're going to walk around. Let's get a tour of your shop, your offices, and your physical plant here. It's really a cool place. Dave has really got it looking good, especially this modern days. The whole place.
So this building that we're in here right now was built in, I think, 1938. It's one of the few dock height buildings in Santa Barbara, which works well for us for loading and unloading.
Dock height. So the
Dock
building
height.
is raised up
Yep.
to the level of the dock.
And a little
Semi-truck dock, right?
a little tidbit, even though we're in a FEMA flood zone and we're roughly 3 feet higher than the line of the FEMA flood sign, we still have to pay flood insurance.
This seems right, Dave.
It's not, it's not, yeah, but we do.
No.
Yeah, you wanna put that on? Can you help me put that on?
And I'm actually going to turn this off. Okay, we're back recording. Dave James is out in his outer office where Javier is sitting there doing something probably shouldn't be doing. So let's take a look. What are we looking at here?
Rodney, excuse me, it's Linda. Can you hear me?
This is my father's first company.
Pardon me?
Never mind. The captioning wasn't on, but then it just went on. Thank you.
You bet.
And my father, Canyon, my mom, Jenna, myself with a beard here, my sister, Karen. His first company was called Casa Plastering, which became Casa Insulation, which became Casa Insulation Energy Conservation Store. And we opened that up in about 1977.
And your dad looked that way his whole life. He never changed. He never got any older.
He didn't. And then this was Santa Barbara Insulation, which we started in 78. And as the picture, this is taken in about 1983, 84. Yeah. Also a little round of golf with my dad. That would be a good plan. Yeah, we just 1938. 1938.
Yeah, don't be put off by this. He's really.
So this was Brian Cranston's beach house that he built down, Allen Associates built. It's went on the market for 4.5 million.
Any of you guys watch The Honor? Your Honor? 8 episodes on Prime Video with Bryan Cranston. It's really worth watching.
Are you doing Grossman? Grossman. Who's Grossman? Grossman on the second one. Yes. Yeah, for DD4? Mm-hmm.
No, RCH.
I don't work for Rich. I don't work for Rich.
No?
No. And then of course there's the bookhouse, famous bookhouse.
Oh, yeah, look at the state it was in.
Yeah. Back in 2013. Was it? Okay.
Wait, that's a picture of me. Is there a zoom on this? That's a picture of me right there. I think.
And this is a job we did for Ed Begley Jr. So let's see. No, it's in Sherman Oaks. Sherman Oaks. Yeah.
Well, went to graduate school and graduated from it.
So you want to go look at the warehouse?
Yeah, I'll do it.
Let's go this way.
Okay. And out this way is a random parking lot, bedrock.
Yeah, we're doing some new construction outside. Yeah.
And new stairs.
Well, we've just kind of moved the stairs.
Dock height, you know what dock height?
Dock height, so
Trucks can just
back right in here.
Load them up, move them out. Come on, bring in the next one. And look at, oh my God, you have your own product in your own building.
Yeah.
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 So great.
So all the foam in the ceiling here was leftover foam that well, it has a shelf life of about 6 months. So some of the products that we had were getting close to about that time. We decided to insulate our ceiling here this year, and we're almost done. We need about another half drum set. We'll be done.
Just from leftover from jobs.
From
use it all.
didn't quite use it all, and some of the material was donated to us by manufacturers wanting us to try out their product.
So like is that yellow different than that yellow?
Yes, this is open cell. This is closed cell.
Wait, which one's which?
This is closed cell here.
Oh. And if now that you know what to look for, you really can't see. Now that I know what to look for.
It's more of a popcorn effect with the open cell than the closed cell.
Yeah.
And this is also a way for us to train installers to learn technique. So, so all the guys that
just point and shoot, right?
no, there's a lot of technique to it. So, you know, our seasoned installers were able to train some of the new guys to learn here instead of on somebody's job. We'd rather them, you know, learn where it's not going to be an issue.
Good idea.
Mhm.
What are we standing here? What's this product? What are we standing
So what do we got here? This is our 30. So this is like we talked about how they shrink wrap it. So we have inside of here 1, 2, 3, just 4 inside of here. And this is our 30.
Now 100 square feet?
No, these bags are about 60 square feet, I think it is.
58.66 square feet.
Yeah, 58. Depending, they always change. There's 11 pieces in there. But it's 10 inches. 10 inches thick. So that's 12 feet times 4. That's almost 48 feet high.
Yeah.
16 inches
Yeah.
wide.
And 16, not
And
14 and a
14.
half. 16, so you press it into a 14
Yeah.
and a half inch stud, baby. It's very
All-
versatile.
All our 30 products are 16 inches wide, except for high density in our 30s.
Because these days don't compress very well.
They don't, yeah. They actually cut it at 15 and a quarter.
Our 30s are 16 too.
Mhm. We don't have any high density R30 here that I know of.
Here's the stuff, these eco vats and what we have right now.
Yeah, now, the difference between this and the old yellow material
Yeah.
is basically the binder. The old binders were formaldehyde-based binder, which made the fibers really kind of strong and adhere together like a glue, but also made them strong enough to penetrate your skin and make it really irritating. So Knauf, who manufactures this particular product, came up with the idea to come up with a vegetable-based binder that is a lot more eco-friendly, and it doesn't make the fibers as irritating.
Yeah, I found the same irritation.
Absolutely.
A little bit today when I was filming, I was touching something.
Mhm.
Usually you touch that little part of it.
Yeah, definitely. Yeah, it definitely hurts, you know? So we have all different widths, R values, depending on what products that we need for. Yeah, that's pretty much the common, you know, R13, R30, R19, those are the most common products.
Yeah.
Over here we have R15.
Yeah.
And the R15, they have 5 bags that come in the back.
These are as expensive as the R30, right?
Yes,
And they can go in 3.5 inch wall.
correct.
Just dense.
Very dense and very heavy. Yeah, a lot of weight to them.
Oh, yeah, no kidding.
Yep. Yeah, about the same.
And then this is the chemicals.
So these are the spray foam products that we carry here. All the foam that's right there will do more than all the fiberglass in the entire warehouse, probably by 3 times. As far as the volume R value.
Foam that you could make by, you combine
A and B.
2 of these products, right? And you have 50 equal parts.
Correct.
So that's enough to make enough foam
Mhm.
to equal every bat in this place 3 times in terms of R value and density.
Yeah. And all of these drums are recyclable.
So
The only thing that's not recyclable is the plastic.
other than the cost, if it's more than that, what's the down? What's the down?
Well, there's no real down to it. There's really more of where is the best use for the particular product.
Well,
And
one place we know of is volume
Volume
sealants.
sealants.
It's pretty much written into the plant.
Well, they came out with a code, the International Building Code, I think it was in 2006, going with non-ventilated roof assemblies using an air impermeable product, which spray foam is air impermeable. And the way to look at air impermeable versus permeable, if you think of if you're a snow skier, you want to have a jacket that doesn't allow the air to go through it. That would be air impermeable, so it doesn't allow air to move through it really quickly. Whereas this particular jacket I have on here is not air impermeable, so when it's windy, it just goes right through it, kind of like a cotton sweatshirt. Fiberglass is like a cotton sweatshirt. It does not like air movement through it. And air carries moisture in a ceiling assembly, like a vaulted ceiling assembly, that air can pass through the fibrous material, keeping the temperature and the moisture as it's passing through the material, and hit a cold surface, oil condensate. Another way to look at it is like you pull out a cerveza out of the refrigerator and you want to keep it cold. What do you put around it? You put a koozie. That koozie's insulation. And it stops it from sweating. And it keeps your beer cold longer.
Yeah, or just figure cold night, the roof's getting cold, you're cold, it's cold outside, so the heated the heck out of your house, all that hot air heats up your lid, heats up the fiberglass, you get condensation. Fiberglass gets wet. It's virtually no place to go. So all of a sudden you start getting rusty drywall screws and your ceiling stuff like that. So that all got noticed, and the fix for it initially before spray foam
Was ventilation.
was ventilation. You had to like notch every other bay, and then vent every other bay, or vent every bay out from the ridge and to the eave, and it became a big. Or do 2x12 rafters, go in 10 inches of insulation, and 2 inches of air gap in between for air movement. This
code requirements for ventilating a roof assembly like that are very challenging. They require, presently, code requires every bay to be ventilated from eave to ridge, every bay, by 1 inch difference between the fibrous material. And you throw in a couple moment frames, you throw in a skylight, you throw in a heavy beam, complicated framing, whatever, hip roofs. They're really super big challenge to be able to deal with. And the challenge with ventilated, non-ventilated roof assemblies is that this condensation could take 10, 15, 20 years to show up. And then all of a sudden you're looking up at the ridge and you see black mold or a mold, and you're like, where did this come from? And it could take a long time for it to happen. So,
Yep. So spray foam
eliminates that
you're
problem.
perfectly poised to take advantage of something that's happening that's not a bad thing, it's a good thing. It's just, in my opinion, the advent of insulation and the technology that's taken us from where we were in '68 to where we are now, we're just bettering the quality of our lives and our building envelopes. We're just making better buildings. And Dave, you are forefront in our building. Now, Dave, I've known Dave since I started in this business. I had a licensed contractor since '81, so probably at least since then. And then we were on a board together
Yeah.
for a long time. I was on the same board as board member, vice president, president, ever, like well over 20 years. And Dave, you were president for at least
3 years. They had to change the bylaws because my vice president backed out at the last minute and I couldn't pick somebody to replace him. So we changed the bylaws for me to be a president for a third year.
term president. See,
One and only. But I hope I'm the only one. That's a lot of work.
An incredible golfer too, I might add. So I don't think I can add much. Do you want to show us what you guys are doing out here? So we walk out here and look.
Let's go around the other way.
Okay, let's go this way. So how sophisticated is the equipment to do de-icing?
Very.
Mixers and pumps and sprayers. Blowers, do you have just one dedicated truck?
I have four separate trucks, and a typical setup, including the trucks, about $120,000. We have a new truck that's on order right now. Should be here by the end of the month, and it's the latest technology that's on the market. It's unbelievable. And we
All rigged out, all set up for your
set up. What?
Okay.
Well,
All set up. Just
he gets too friendly with you.
pull of the stick. Pull of everything you need, just ready to start spraying foam.
Ready to go. I mean, we'll probably add some few bells and whistles to it. I mean, just little local things we like to have that they didn't come with. But what we're doing over here is the concrete in this location. This concrete's about 85 years old, and it's sort of cracked in the corner here and got a low spot. And so every time it rained, it got a puddle there, and it got worse and worse. So we had a staircase system here. We're moving that staircase over to against that wall of the building next door. We're going to extend this wall on out a little bit farther so we can back two of my big trucks side by side and back right up to it.
This is great. And you guys are such a great niche, bedrock, kind of like bedrock.
Yeah, it's pretty much the part. It's kind of crazy in here.
Where you want to be, man.
Definitely gets crazy. You see the bent beam up there? Somebody hit that hard.
It's pretty small. I mean, ready for what it's doing. All it needs to be. Gosh, that big. I was looking at this big.
Yeah, somebody hit it with a big truck or something.
So, anyway, let's say goodbye to Dave. Dave, phenomenal. It's so good to see you and interview you. You know, you're going to say that well. Thank you. I mean, I got a million questions I should have asked you.
You can always go to our website at www.insulatesg.com. There's a lot of cool learning tabs in there to learn more about insulation and answer some of the questions you may have about products in general.
And also, I'm tasking the whole class to find out where
Okay, over now.
I'm sorry, I had to do that. I just had to do it. Okay, hey, so that was interesting, huh? Did anybody else find that interesting? Because I sure did. Just watching it again and watching
Yeah.
the video, I just really liked
He was
it.
very informative, I thought. He's a good interviewee.
I agree. Yeah, he's
Very
very
knowledgeable.
articulate and talks slowly and enunciates clearly. We do know
And you
Linda.
Ryan Reynolds.
Jose thinks he looks like Ryan Reynolds, the actor.
Yeah. Are you gay, Jose? No, just kidding. He does look a little bit like, I'll tell him that that's a great compliment. I wish somebody would say that about me. People usually say I look like Bela Lugosi. No, just kidding about Bela Lugosi. But then I imagine there's only like maybe one person here that even knows who Bela Lugosi is. I'm sorry, raise your hand if you know who Bela Lugosi is or was. Nobody, not even one person. Okay, so Bela Lugosi played Dracula in the first black and white movies that Dracula was in. Bela Lugosi. He was from somewhere in Eastern Europe, played the Transylvanian. So yeah, I thought that was super interesting from Dave. All kinds of stuff, but the fenestration, I want to talk to you a little bit about fenestration. I'm going to go ahead and pin myself. So fenestration is it's about the openings in your house. It's basically about the glass in your house, but it's really about the openings in your house. Fenestration, the word, the etymology of the word is from the Greek fenestra. And fenestra means opening in Greek. So fenestration is the openings in your house. John donated, they've been scattered, John, so this may or may not be good, but yeah, fenestration is the openings in your house, the glass in your house, which is, it's not that complicated, but it's a mathematical formula that's used based on square footage of the envelope, square footage of the walls, square footage of the glass area, and you're allowed a certain
Excuse me,
amount.
Rodney. Rodney,
Yes?
excuse me. Could you just repeat that one more time?
No? Okay, that'll do it. From where? Fenestration is in building science today, having to do with the glass in your house, is based on a mathematical formula where they take the building envelope size, square footage, the square footage of the walls, the roof is somehow figured in as well, and then you have a coefficient that comes up with an allowable amount of square footage of glass. And if you go past that allowable amount, then you have to mitigate that in the Title 24, which governs all our energy and seismic codes and accessibility codes. You have to mitigate that by doing various things, like an on-demand water heater is one, solar is another, but beefing up insulation, which is what David was talking about, beefing up the insulation. So in other words, if you if you're called for an R30 in the ceilings, then maybe you can somehow get an R60 with a closed cell foam. And that would mitigate some of the larger glass, the more glass that you're supposed to have, just to be in conformity with the IBC, with the International Building Code, and what it says you can have for glass, total square footage of glass. I'm hoping you can see this, but prior to us using closed cell or open cell foam, the Icynene foam, the half-pound foam, prior to that, I was building and the codes changed radically one year when this whole ventilation thing came up. So if you wanted a vaulted ceiling, so let's say you had ridge, oh man, I don't think that's very dark. It's not very dark at all. Yeah, John, so the stuff you brought, it's all mixed up now. Okay, that's pretty dark. All right, a ridge. And then rafters, say, maybe the rafters, let's say the rafters are on top of the ridge, doesn't really matter. Rafters. And they sit on top of a plate. And an exterior wall. And so there's a freeze block. I'm going to show it solid. I should show it dotted. But it's a block in between rafters. As the rafters continue, another rafter, these blocks are solid in between on the top of the plate. So when you had a rafter bay in a vaulted ceiling, and typically you'd have a ceiling joist, right? Running this way. And that would be insulated. So with a vaulted ceiling, we would insulate the rafters and then drywall, which would cover the insulation. So, but to get the ventilation that we needed, because it was found out that these volume ceilings created this air transfer of hot and cold air that caused condensation in water, and to mitigate it, you'd have to get an R30 in here, you'd have to frame this rafter roof system in 2x12. So you had 11.5 inches. And then you'd have to put in tip, because R30 is 10 inches. So you'd put in 10 inches of R30 insulation. Insulation back. And you'd have to leave that 1.5 inches above empty, and that allowed, and you'd also have to have an O'Hagan type or some kind of a ridge vent that allowed air to draw through this airspace and create air movement, and then be drawn out through another vent in the face of the freeze block out into the air. See, it bent every single rafter bay, and it created problems and expense. And you have to resize from 2x10 to 2x12 and do all kinds of things that, whereas this may be even 2x6. This may be engineered so that the span is such that you could use 2x6. And now by filling it full of spray foam, you don't have to do any of that. You don't have to do a ridge vent. You can do a regular ridge, no vent to the ridge, and no venting through the freeze blocks. So you have no places for critters to get in, no places for water to get in. So yes, we could vent these spaces, but then we created a problem in every rafter bay, a problem of weatherization and keeping things out that we don't want in houses. So, all right, we went another solid hour. We're going to take a break, and we're going to come back and do some breakout rooms, some brief breakout rooms. And right now I've got 24 after. Let's take a short break. Well, I'll come back at 35 after. I'll give us 25 minutes. Come back at 35 after. Okay. Okay. And I'll, I didn't pause the recording before. I think I will. Pause the recording. And somebody will help me remember. Okay. Zoom.
Oh,
So come on back, please, for the last 25 minutes of our. Okay, we got everybody, Jose, Kevin. Okay, Brenda's here. So here's what we're gonna do for about 10 minutes. Yeah, about 10 minutes. I'm gonna give you 10 minutes. We're gonna go to breakout rooms, 4 people per room. And then I want you, in the 10 minutes I give you from when we start the room, I want you to just kick it around what you saw, what you heard from Dave. And I would like you to come up with the most interesting thing and the most valuable thing. So 2 things. And I'll just ask one of you to be a spokesperson. What did you find to be the most interesting thing about what you saw and heard today? And what did you think was the most valuable thing? So get some kind of consensus. And it doesn't have to be one thing. If you guys got a couple, you can do it. So here goes The breakout rooms, create, assign manually, create. Okay, so room 1, I'm gonna put in Ugo, Linda, Katie, Lindsay, and then 3 more, Jose, John. I think that's it. And that leaves me 1. Wait, yeah. That leaves me 1, 2, 3. Okay, so you guys are in that room. Okay, add a room, and then Brenda, Colby, Jose, and Kevin. Okay, so you guys are open. You're in your rooms. Go. All right, all right.
Isoni. So, so he wanted us to what? Find out the most interesting thing and what else? What was the other thing? I can't remember.
Is it most important?
Most important and
Most important and most interesting.
Okay.
Valuable?
I think the most interesting was how the fish crap out sand. As if you asked
That
me.
was-
That's if you asked
That
me.
was kind of interesting. I was
That
like,
was.
yeah, I think that's a good point right there. Jose, you want to be the spokesperson and say that one? Because
Somebody else could be a spokesperson.
Oh, yeah, I was spokesperson last time.
I'll just say that's pretty interesting.
Savings.
Definitely. I agree with you. I was amazed as well myself.
Would that be the a good contender for most valuable?
I believe so.
Yeah.
Yeah, I
Okay.
think
So the long-term benefits of spray foam in the house.
yes. Yeah, compared to the regular. Um,
How is glass made?
According to Glass Alliance Europe, glass is made from natural and abundant raw materials that are melted at very high temperature to form a new material, glass.
Where does silica sand come from?
According to Select Sands Corp, silica sand is quartz that over time, through the work of water and wind, has been broken down into tiny granules.
Quartz. Interesting. Quartz. Non-coastal. Right.
Rodney, I lost my box again.
Wow, that's weird.
I know. I think it happened the last time too. I got it when I was in the breakout room. I just didn't come with me here.
What is your problem? Okay, Linda, let's see. More. Make host allow withdraw closed caption permission. So that's all I'm going to do, right? This should not kick you out of the damn place. If you get kicked out, I'm not going to shut down the whole meeting. But okay, I'm withdrawing. Linda's still here. That's the good news. I'm going to do closed captioning, assign a participant to type. Or that work, Linda? Linda?
Yeah. Wait, yeah, I got it now. Thank
Okay.
you.
All right.
Thank you very much.
No problem. Okay, so let's see. I hope you guys had spirited discussions. I dropped in on just a couple of them for briefly. I dropped in on a couple of your spirited discussions briefly. So tell me about, let's see, the group two. Who was group two? Who's going to tell me? Actually, who's going to, yeah, group two. Tell me, what'd you guys come up with? What'd you think was the most interesting? What'd you think was the most valuable?
You're right.
Yeah.
Okay, so again, I get to be spokesperson. So the most interesting, we had a couple of them. The first one the guys wanted was that the fish eat the coral and poop out the sand.
I love that. I didn't know that either. I think that is super interesting.
I actually want to look that up because I thought that was interesting too.
Well, would you please fact check that for us and then let
Yeah.
us know next week? But very interesting.
Yeah, wasn't
And
Jose supposed to fact check something before too?
And I did.
He did, the first law. He did that. What,
Oh, yeah. And then
what was your other one?
and then our other most interesting is we had another one. The bonded logic, isn't that the one that was the 100% cotton? So that they used recycled denim, but I know it's no longer available as of February of this year. But we thought that was kind of cool, you know, that they used recycled denim for that. I'm like, is that why everybody wanted to sell their Levi's and stuff? But and then most important, we kind of thought insulation was all really important, but we thought like how in regards to conditioned space, that the house itself needs the higher rated insulation versus like say the garage and the attic. And so that they can actually separate that. And you know how like well, I know you know, but how the garage, the wall that attaches to the home is actually an insulated wall for the home and such. So we thought that was pretty important.
Stop.
Sorry about that. But when I first started in this class, I remember hearing about isonine. And so immediately I looked that up because I had never heard of that. And I worked for an insulation company for a little while and a plumbing company, but I thought that was really neat. And that was a good name for it. So when they're talking about changing that name, I'm like, that's a perfect name because it kind of looks like icing.
Yeah, no, that's a great point too, because isonine has become for me and a lot of people, it's become like Kleenex, right?
Yeah.
Kleenex is tissue. Kleenex is a
Right.
brand of tissue, but when I say Kleenex, people think of tissue just the same way isonine, closed cell or open cell foam. So, okay, group one, what did you guys come up with as most valuable and most interesting?
So for most interesting, we thought his analogy of having your toes stick out of your blankets and how cold that is, and brought us to is it's so important that the whole envelope is insulated. There's no holes. We thought that was most interesting. And then for most valuable, Hugo brought up the long-term benefits of spray foam. How it can, especially with closed cell, it can help resist moisture. It's an air barrier. And the ease of insulation into hard to get to places. It completely fills the cavity.
Yeah, I agree. So that was incredible. I mean, when I say incredible, it's kind of it's a oft used word by me, but I am so blown away by all the things it brings up. Something as simple as you know, as a contractor and a builder, when I think of insulation and insulation contractors, by the way, what do you think? It works, right? I got this from Dave, Insulate Santa Barbara. You guys go by and visit him. I bet you could get a hat too. But where was I? You know, when I think of insulation, I don't think of, you know, I make fun of Dave's job being so easy. You know, he's got like a few choices and a few ways to do things, and then they got the Icynene trucks. But that's really oversimplifying a job that's not all that easy and has so many components. And I love to become aware of how interesting a job is and the physical aspects of it, the logistical aspects of it, and God, I'm searching for a word I can't find. It's just not coming to me, but it just brings up things to me like, where does fiberglass come from? You know, I've been known about fiberglass my whole life. I had a Radden boat out of fiberglass hulled boat. Actually, it was 3 layers of 1/4-inch mahogany, Philippine mahogany plywood, cross-laminated, and then fiberglass on each side. But I've worked for fiberglass. I know fiberglass, but truthfully, 72 years later, I finally decided to find out how it's made, where it comes from. I really had no idea. Just fiberglass. I just took it for granted. It was a product called fiberglass, and it was always there. I guess maybe I thought it was harvested from trees or made in a lab or something. I don't really know what I thought. Truthfully, I never thought about it until very recently. I thought about, where does this stuff come from? And then, bam, when David said sand, and I went, yeah, duh, glass, you know, but I don't equate fiberglass, and I equate fiberglass now with bad insulation. I don't equate it with sand at all. So that was another interesting revelation. This is a whole gigantic billion-dollar industry that's driving a lot of what we do as builders, building quality, air quality, building envelopes, thermal and sound insulation. It's huge. So another thing it brought up for me is, how do you make glass? I mean, I know glass is made from sand, and I know soda ash and lime is involved. So I looked it up while you guys were in your breakout room, and glass comes from silica sand, but silica sand, I still haven't got there yet. I still don't know. I think it's mined, but I don't think it's from the beach at all. Like, it's basically, it's a quartz sand. So it's made up of pieces, ground up, degraded pieces of quartz. It has to have 95% silicon dioxide, which is the main component of quartz. It's SiO2 for what it's worth, and to be glass sand, to be able to be made into glass. Anyway, it's just all of it is fascinating to me.
Yeah, Rodney, I used to work in the mines, and we used to mine silica. That was our main product. And you'd be surprised what it goes into. It goes into toothpaste, lipstick, makeup, all kinds of stuff.
Whoa. Stop for just a second. Where was this plant at that you mined at? Or this mine?
Actually, James Hardy actually owned the plant, and we were a sister company of it, but we used to produce everything for James Hardy.
Oro Grande.
Out of Oro Grande, California, where I live at over here, probably about 35 miles from me.
So, okay, so that's near Hesperia, right?
Yeah, and Oro Grande's probably about 35 miles from me. And we used to mine there for years and years, you know. And then when this thing hit, this recession hit and stuff, the first one back in 2008 and 9, it got really bad. But anyways, we used to have to take core samples, and the core samples would be sent out. And if it didn't come back 98%, we couldn't use it.
Right.
We could use it for like cement and stuff like that.
Yeah.
We could use it for ball mills, you know, for walls, whatever. But when it came for glass, if it wasn't 98%, because by the time it shrinks down and we crush it into sand, it would shrink down to about 96, 95% was the minimum that they wanted. But it was an interesting process, you know what I mean? Because we'd have to put it through a sand max, and then if they wanted it finer, we'd have to put it through ball mills, you know, and just
So you guys actually made the sand from silica, from an ore, from a quartz ore, right?
Yeah.
It didn't come as sand, like you
No,
didn't
it's
walk out
sorry.
on the beach on it. It was
No.
big old giant rocks,
Started off
ore
as
that got
huge
crushed
rocks.
and made into sand. That's
Yeah.
insane.
Rocks the size of Volkswagens, man. They go into a jaw crusher. We used to drive haul trucks that carried 250,000 tons at a time. These things were huge.
They're scary coming at you too.
You know, they're like 12 stories high.
Yeah.
You got a cockpit, you sit in the middle of these things, but the equipment you use to get it, but the way we used to have to take the cores, and after the core, Rodney, we'd have to blow everything up to turn in, you know, to get the rocks to a good size. Then we'd go in the pit, load up the trucks, and we'd start crushing it, and just different size sand. And of course, you know what I mean? We sold rock there too.
Yeah.
So, you know, we put it on our screens, on our shaker decks, and it would tell us, okay, this is 1 inch rock, this is 2 inch rock, this is 1/4 inch rock, this is P rock. You know what I mean? Depending on what you want, because we sold stuff to like a lot of oil fields. You know what I mean? Because that's how they clean their oil pipes and stuff out. They put sand down on them to stop it up, and then they clean what they need to clean, and they clean all the sand back out, suck it back out, and then they release the oil back again. Because you know, trust me, it's an amazing system. But sand is actually something that you could just take and use in so many things. And the thing about it is, as time goes through, it just goes away, man.
Yeah, so wait, you know what? I'm gonna mute you for a second. So this is amazing, even more amazing to me, that sand, right? When I used to think of beach, you know, glass made from sand, I think of, you know, those white sands in Florida or up in Carmel, you know, and there's some place where they're getting sand, but they don't get sand from our beaches. It's mined in these places. And so sand is not a renewable resource.
No.
There's a finite amount of it in the earth. It's not unlimited. It's like oil. And I wonder how much there is of it. Are we at some point going to run out of glass? Are we going to, because really that's basically, but not just glass. Like you're saying, that stuff gets crushed to powder, right? So at first I was thinking, wait, sand and toothpaste? That's why that dang toothpaste is so gritty. No, it's made into a powder. And it's interesting, and I'll tell you about this. I'll tell you all an anecdote if somebody reminds me next week about talc as a mineral, which is in a whole plethora of products. And I went into a talc mine. I have a big, if I remember, I'll bring a big piece of talc ore. And I find that was a really interesting journey for me to learn about talc and to go down in a mine. But I hope you all had as much fun with this as I did. I actually had a blast doing this, learning about something I've been using and been involved in for decades, that I all of a sudden now know so much more about, and know so much more about other things. I've expanded my awareness and my knowledge so much thanks to you, thanks to CT 111. And thanks to you prompting me to want to get this material out to you for you to learn. Consequently, I learned a whole bunch of new stuff too. So it's pretty exciting for me, which is what happens. And I thank you all. And I want to just tell you that if you shop at Trader Joe's, if you want to stay away from these candied pecans, because I expect this is what cracked was what it is probably like, even though I don't really know. But from what I've heard, these candy pecans are crack-like, so do yourself a favor and stay away from them. And I'm really, my ulterior motive is that if you stay away from them, there'll be more for me. Okay? Yeah, that's bad. Okay, so we're past 12. I will see you all next Saturday at 12. And like I said, it's always a pleasure being with you all. Okay.
Have a blessed
Have
week.
a good one.
Thank you.
Yeah, stay safe, everybody. Stay safe, stay sane. When I see you next, we'll be living in our trailer at Rancho Oso in the Upper Valley. So maybe I'll I'll have some really fun adventures to tell you about.
That'd be cool. That would be really cool.
Okay. Adios, John. See you
Bye.
soon.
Take care.
Good job, Lindsay, Katie, Linda, everybody. Hugo, good to see y'all.